Okay, hello pre-calculus people. We're going to be going over secant graphs. This should be the first video you see out of the series of videos for this week. Probably going to be only about 3 videos because we're going to do secant because we did cosecant last week. We're going to be doing solving a trig by factoring, so a couple different factoring problems. We're probably going to stop it at that. We'll save some indifference, half angle, double angle. We'll save that to the following couple weeks, okay? So right now we're going to concentrate on secant. So the way we did cosecant, if you guys remember, the way we did cosecant, the previous one, is we remembered cosecant was the reciprocal of sine. Okay. Well, in this case, just like this, secant is going to be the reciprocal of cosine. So I'm actually going to set this up like a cosine function. I'm actually going to graph it like a regular cosine function, and then we'll see what the secant looks like. Okay. So same stuff, really. It's really not that much more complicated. Amplitude is A, absolute value of A, which is just 1 in this case because the A is the coefficient here. Period, 2 pi over B. So remember, that's an A, that's a B, and then this is over here, it's minus C. So it's BX minus C. So it doesn't matter. Our B right here is 2. Okay? So 2 is just going to get us 1 pi. So our period is pi. So what does that mean? If a standard period is 2 pi, let's try this. Pi over 2, pi, 3 pi over 2, 2 pi. The standard is 2 pi. Standard period is 2 pi. But the fact that our b is 2, that actually crushes it down to being only a period of pi. So it's going to be a lot more compact, more wavy rather than wider ways. It's going to be a little more compact. And then lastly, phase shift. So please be careful with phase shift, C over B, but be careful. If this was minus pi over 2, our C would be pi over 2. Since it's plus pi over 2, our C is actually negative pi over 2 divided by B, and our B is 2. So negative pi over 2 divided by 2 is going to give us negative pi over 4. That is our phase shift. Okay, so we have our period, our amplitude, and our phase shift. So let's talk about this real quick. I'm actually going to first think about what does a standard cosine function look like? Well, a standard cosine function, let's think about the amplitude first of all. The amplitude is 1. So I'm only going to really go up 1, down 1. I'm not going to go past that. So if you remember, a sine starts at 0, goes up, goes down, goes up. That's what a sine looks like. In this case, if you guys remember, the way cosine goes actually starts here at 1, would go down to pi over 2, down here, up here, up here. It would go like this. Cosine would go like this. So, but there's a couple things to take into consideration here. We're not talking about a 2 pi period. Our period's only pi. So instead of going down here at pi over 2, it's actually going to be cut in half everything. It's going to go down here, up here, up here. So the way it's going to go is it's going to come down, then back up. So if you notice what happens is, and actually, well, yeah, and then it's going to start coming down again. So it's got a period of pi here. It's going down here, going here, and then back up again. Let me just make sure. Yeah, that looks good to me. And then it's going to repeat again. It's going to go down here, up again. Okay, so it's going to just repeat that over and over again. Okay, so you see the period right there. It's going to be a period of pi. Let's talk about what's going to happen next, though, because sure, this is a period of pi. That's great. That's great. Our phase shift, though, is negative pi over 4. We got to shift this entire thing to the left because it's negative. We got to shift it to the left by pi over 4. Well, this is pi over 2. So this right here would be negative pi over 2. I don't want to shift it negative pi over 2. I want to shift it negative pi over 4, so somewhere in the middle of that. So here's what I'm going to do. I'm literally going to take this and shift it to the left like that. So now this is what it's going to look like. I'm going to do this one in red. Ready? Okay, so I'm going to shift here. So it's going to go to the left. So that means this is also going to go to the left. This is also going to go to the left. This is also going to go to the left. This will also go to the left. Everything's going to be shifted to the left. So now this will look something like that. Okay, and the same thing with all of this. This will also go to the left, to the left, and to the left. Okay, so now we have. So you know what? Why don't I continue doing that? Actually, to make it clear, this will shift to the left. This will shift to the left. This will shift to the left, and so on and so on. So it's going to look. Okay, it's very crusty, but you guys get the point. Okay, so let's talk about what happened. In black is the cosine function. However, we had to turn it into a period of pi. So instead of going all the way through, finishing up at 2 pi, it's finishing up at pi. 1 pi period in black, cosine. And we took this and literally shifted it, phase shift, to the left pi over 4, because our phase shift is negative pi over 4. So here's what I'm going to do now. I don't need the cosine function in black anymore, because we're just dealing with the red one right now. So here's what we're going to do, which is the last step. What we have currently is the cosine function, cosine of 2x plus pi over 2, which is cute, which is great. That's awesome. It's not what I asked for. I'm asking for the secant. So let's do the same thing that we did when we were graphing the cosecant function. What you're going to do is you're going to get what this is called. This is your maximum. You're going to get this. And we're going to draw what looks to be a parabola, right? It's not really a parabola, but what looks to be a parabola. I'm going to draw that too. And I'm going to draw that too. And I could just keep going. I mean, anyway, I got it. So let's observe this and realize where the asymptotes are going to be. So the asymptote is going to be visually, I can see it. Asymptote's going to be right there. Asymptote's going to be right there. Asymptote at 0. Asymptote at negative pi over 2. Asymptote at pi over 2. Asymptote at pi. 3 pi over 2. Do you guys see the pattern here? Asymptote at 2 pi, and so on and so on. And this will be obviously like this. Okay, and so remember, your parabola here is kind of like it's going towards the asymptote, getting infinitely near, but never actually touching the asymptote. Okay, so one thing I want you guys to observe from this. We were talking about a period, okay? So we started the graph here, and we ended it. We started the graph here, and we ended it here from negative. We started it here, and we ended it here, okay? So this was our period. You see where this dotted red is? I want you guys to kind of keep in mind what this means, all right? And you only need to do this visually. Asymptotes visually as well. I mean, I just need to, at this point for this next quiz, you just need to understand. What is the endpoint? Well, 2 endpoints. Here's endpoint number 1 at negative pi over 4. Negative pi over 4. Here's endpoint number 2 at what's between pi over 2 and pi, which would be 3 pi over 4. Okay. This middle right here, so in the middle of these two, this guy right here, which is pi over 4, that will be our midpoint. And then these two right here would be Q1 and Q3. Okay? Endpoint, endpoint, midpoint, Q1, Q3. And that's it. Okay? So you got this whole graph ready. Now I'm going to flip this over. We're going to get the homework questions. Okay, now this is just for my reference is the unit circle, so you don't have to worry about that. But anyways, here we got it right here. The homework questions, they're all secant functions. Only difference with number 2 is that it's got an amplitude of 2. Be careful. Also number 2, the C says plus pi, so when you're calculating phase shift, be careful. For C, you have to put negative pi. And that's about it. The first two have a standard 2 pi period, as you can see, because look at the B. It's 1, so it's not going to affect the period. However, this one, similar to the one we just did, is going to be the truncated period. These are the ones that get tricky when the period is shrunk down or stretched out. That's when it gets a little more tricky, like the one we just did. Okay. Stay tuned. We'll have you can, after you're done with this and you put that, you can go watch the second and the third video, which will be on solving by factoring. Okay.